In today's session, we are going to see about static and dynamic data structure. What is a data structure? The way of storing and organizing data in memory is called as data structure. That is, here the memory plays a vital role in the data structure. To execute a program, memory allocation and its usage plays an important role. Why the memory is that much important? Because storing the data into the memory, organizing or arranging the data in the memory and retrieving the content or the data from the memory for processing, and after that storing the data into the memory. All these things happens in the memory during the course of execution. That is why the memory is that much important. Based on memory allocation, is there any types of data structure? Yes, there are two types of data structure. Number one, static data structure, and the other is dynamic data structure. Now let us see what is static data structure. Static data structure means allocation of memory happens before the execution of the program. That is, when the memory size is fixed, then during the compile time the memory size gets fixed. Example for static data structure is an array. Let me consider this array A, and array length here is 7 and number of elements stored in the array is 3. Number of free spaces is 4. So array starts from 0 and it ends at 6. Since it has 7 locations to store the value, it starts from 0 to 6. And the address is here. Since this is an integer array, it starts from 0. Every array location takes 2 bytes. So that is why it is 100, 102, 104, 106, like that it goes on. These addresses are consecutive in nature. So in static data structure, the memory spaces are contiguous in nature or sequentially allotted. Is it compulsory to use the free space in the array? No. You may or may not use the space. Advantages of static data structure. Memory is fixed. That is, adding or removing data item in and from the memory is not at all a problem in static data structure. Number 2, no need to check data size at the point of time during execution. The disadvantage for the static data structure is, since there is no compulsion in using the free space, allotted memory may get wasted here. Now coming to the dynamic data structure. The memory sizes of the structure is not fixed during compile time. Then when it gets fixed during runtime. That is, whenever if memory is required, the memory allocation happens. That is what, by using the memory allocation functions malloc, calloc and realloc functions. Example for dynamic data structure. Linked list is the best example for dynamic data structure. Here, this is the representation of a linked list in which addresses of the every node is given as 1005, 2008, 2010, which are not contiguous in nature. Which means that the free memory spaces are allotted whenever you are requesting for a memory, and every node gets connected with the other node by using a next pointer which holds the address of the next node. If I want to create a node during the execution, what functions are used? The memory allocation functions are malloc, memory allocation, calloc is contiguous memory allocation, realloc is reallocation of the memory space for the already allocated memory. And for deallocation of the memory, we can use free of function. Advantage of dynamic data structure. Efficient use of memory is happening since we are requesting for the memory whenever we need it. So it is an efficient use of memory. Disadvantage of dynamic data structure is overflow and underflow problem may occur while requesting the memory. That is, there is a possibility of the structure to overflow if it exceeds the maximum allowed memory limit. When the underflow happens, if the data structure becomes empty and request for memory allocation is made, then during that time underflow may occur. Keeping track of size during allocation is required. These are the disadvantages of dynamic data structure. In the next session, we will see about comparison of static and dynamic data structures. Thank you.